In this section, we want to look at kinetic theory of matter and gas law. Kinetic theory of matter and gas law. Kinetic theory of matter. Matter is composed of tiny particles called atoms, molecules, or ions. The kinetic theory of matter postulates that these particles are continually in motion and so possess kinetic energy. I repeat, the kinetic theory of matter postulates that these particles are continually in motion and so possess kinetic energy. It means that particles are always moving, and since they move, they contain kinetic energy, which is energy due to motion. Matter is classified into three states: the solid, liquid, and gaseous states. The particles which makes up the three states of matter differs only in the manner in which they are arranged. The particles which make up the three states of matter differs only in the manner in which they are arranged. For instance, the degree of movement of their particles and not in kind. Any increase in temperature causes an increase in the average kinetic energy of the particles. So the moment you increase the temperature, the particles move faster. Kinetic theory, however, deals with how the arrangement of particles of a substance determine the properties that substance will possess and the state in which it is likely to be found under a given set of conditions. I repeat, kinetic theory deals with how the arrangement of particles of a substance determines the properties that substance will possess and the state in which it is likely to be found under a given set of conditions. So let's look at a few things now on the state of matters. Solid states. Substances in solid state are made up of particles which are very closely packed and are held firmly together by force of cohesion. The cohesion force may be electrovalent, covalent, metallic, or the very weak van der Waals force. This cohesive force holding the particles of a solid are strong enough to prevent movement of the translation, that is, moving from one place to another. The particles of solid can only vibrate and rotate about their fixed position, but cannot translate. The particles of solid can only vibrate and rotate about their fixed position but cannot translate. Hence, solids have definite shapes, definite volume, and are difficult to compress. The strength of any solid is determined by the type of bond and force holding the particles. So that is about the solid, the features of solid. Now let's go to liquid. The liquid state is intermediate in character between the complete molecular randomness that characterizes gases and the orderly arrangement of molecules of crystalline solid. The particles in a solid can move about because they have more kinetic energy than solid and are not held in fixed position. They can vibrate, rotate, and translate. In liquid, the particles move slowly enough that the cohesive force of attraction can hold them together in a definite volume. A liquid therefore retains its volume but has no definite shape. It flows to assume the shape of the container in which it is placed. That is about the liquid. Now let's look at what we have for the gas state or gaseous state. The particles in a gas are relatively far apart and have more kinetic energy than those in a liquid. The cohesive force in a gas are negligible, and the particles are free to move about in all directions at great speed. They are restricted only by the walls of the container. A gas has no definite shape. It occupies the whole volume of its container and may be readily compressed. So that is concerning the gas or gaseous states. Now let's look at change of states. Change of state is brought about by a change in temperature, that is, heating and cooling. When a substance is heated, its constituent particles acquire kinetic energy. When cooled, they become less energetic. I repeat, change of state is brought about by a change in temperature, that is, heating and cooling. When a substance is heated, its constituent particles acquire kinetic energy. When cooled, they become less energetic. When a solid is heated, the particles acquire greater kinetic energy and vibrate more violently. A point is reached when the force of vibration overcomes the cohesive force and the crystalline structure collapses. The particles are no longer held in fixed position but are free to move about, and the liquid state is reached. The temperature at which this occurs is called the melting point of the solid. And at this temperature, the solid and the liquid are in equilibrium. Hence, the temperature at which solid to liquid equilibrium is attained under air at 1 atmosphere pressure is called the melting point. The quantity of heat energy which must be supplied to convert solid to liquid at specific temperature is known as latent heat of fusion. So that is the energy that must be supplied for solid to melt, for it to melt. And at times there are some solids that do not exist in liquid states. They move directly from solid to gaseous state. And we call such process sublimation. Evaporation is the process of vaporization of liquid at all temperature. Particles in a liquid are equally attracted by neighboring particles in all directions. Those at the surface of the liquid body are attracted inward and sideways by the neighboring particles. In evaporation, the molecule near the surface of the liquid acquire extra kinetic energy large enough to enable them break away from the cohesive force binding them to their neighboring particles. Once free, they escape from the liquid surface to become molecules in the vapor state. This explains the decrease in the volume of water. So that is what we see when there is evaporation. When a liquid is heated, the rate of evaporation increases and the value of the saturated vapor pressure of the liquid rises until a temperature is reached at which the saturated vapor pressure of the liquid equals the prevailing atmospheric pressure. When this happens, the liquid is said to boil, and the temperature at which this happens is known as the boiling point. I want to talk about evaporation. Evaporation is the process of vaporization of liquid at all temperature. Particles in a liquid are easily attracted by the neighboring particles in all directions. Now, the process of boiling is very similar to evaporation. The difference is only in scope. Thus, boiling involves the entire volume of the liquid, while evaporation takes place only at the surface. When an evaporating liquid is confined in a closed container, the escaped particles gradually accumulate in the space above the liquid. Hence, the particles collide frequently with one another and with the wall of the container, and consequently exert a pressure known as the vapor pressure. Boiling. When a liquid is heated, the rate of evaporation increases and the value of the saturated vapor pressure of the liquid rises until a temperature is reached at which the saturated vapor pressure of the liquid equals the prevailing atmospheric pressure. When this happens, the liquid is said to boil, and the temperature at that temperature is called the boiling point. Freezing and condensation. While heating causes melting and boiling, cooling causes condensation and freezing. Condensation is a process whereby a liquid loses some of its kinetic energy to a cooler body and changes into liquid automatically. Now let's look at kinetic theory of gases. Kinetic theory of gases is a theory that offers explanation of the law and correlates observed facts concerning the behavior of gases. The theory postulates the following: that gas molecules are in a constant rapid straight motion and collide with one another and with the wall of the containing vessels. The collision on the wall of the container constitutes the gas pressure in the container. 2. That the collision of gas molecules are perfectly elastic. When the molecule collide with the wall of the container, they rebounds like elastic ball without any loss of energy. And 3. Gas consists of molecules widely separated in space. The total volume of the gas molecule is negligible in comparison with the volume of the container. 4. The force of attraction, cohesive force, between the gas molecule are negligible. Number 5. The average kinetic energy of the gas molecule is a measure of the temperature of the gas molecule. The kinetic energy depends on the temperature. Kinetic theory postulates are fulfilled by ideal or perfect gas at all temperature and pressure. So rare gases like nitrogen gas, oxygen gas, hydrogen gas, carbon dioxide, however, show deviation in behavior at low temperature and high pressure because at this high pressure the molecules are close together and intermolecular attraction become appreciable. Now we just introduce ourselves to the gas law by stating them. Boyle's law states that the pressure of a fixed mass of gas is inversely proportional to the volume, provided the temperature remains constant. I repeat, Boyle's law states that the pressure of a fixed mass of gas is inversely proportional to the volume, provided the temperature remains constant. And Charles' law states that the volume of a fixed mass of gas varies directly with the absolute temperature, provided the pressure remains constant. Charles' law states that the volume of a fixed mass of gas varies directly with the absolute temperature, provided the pressure remains constant. So we'll stop here and continue from here in our next discussion. Thank you.